closely at the fabric of reality, and you will find it is not smooth. At the microscopic level, the universe fractures. Energy, light, and matter only exist in distinct, indivisible packets, tiny units of physics we call quanta. For nearly a century, physics has accepted this pixelation as a brute fact. Erwin Schrödinger and the early architects of quantum mechanics built brilliant equations to track these discrete packets, but the mathematics accepted the quantum nature of reality as a starting assumption. The equations worked perfectly, yet they could not explain the physical reason nature divides itself this way. Now, two distinctly different fields of research are converging on an answer. One approach works through the physical mechanics of fluids, while the other maps the pure, abstract mathematics of prime numbers. Synthesizing these two frameworks leads to a specific conclusion. To understand how quantization actually works, we have to rethink the empty vacuum of space itself. The emergent quantization theory proposes that the vacuum is not an empty void. Instead, it behaves like a dynamic, compressible fluid, a physical medium capable of carrying pressure fluctuations, almost identical to acoustic sound waves traveling through water. In specific types of fluid mediums, wave frequencies square themselves relative to their spatial shape, a property known as quadratic dispersion. This physical constraint forces continuous inputs to separate into distinct, isolated spikes of energy. This image displays the vertical, discrete emission lines of the hydrogen spectrum. When physicists apply the mechanics of a dispersive acoustic fluid to the space immediately surrounding a proton, the mathematics naturally reproduce these exact hydrogen lines. The allowed energy states emerge from the fluid's boundary conditions, requiring no traditional quantum rules to calculate. The discrete energy states of atoms arise from physical waves reflecting and sustaining themselves within this specific medium. Quantum behavior is the emergent acoustic resonance of a cosmic fluid, much like the specific tone of a ringing bell. Modeling space as a fluid derives the shape of a hydrogen atom, but it leaves an unresolved gap. The fluid equations require highly specific parameters, exact dispersion rates, and exact sound speed profiles to match real-world observations. The fluid model alone cannot explain what absolute rules tune those specific numbers. The answer appears in pure mathematics. The primorial reciprocity framework is built on the arithmetic of 2310, which is the primorial number derived from multiplying the first 5 primes, 2, 3, 5, 7, and 11. This mathematical framework maps the complex reciprocity laws between these prime numbers. It treats them as an overarching system of instructions that dictate exactly how mathematical structures scale and organize. When we apply this prime-numbered code to the fluid vacuum, the abstract mathematics align with the mechanical properties. The prime hierarchy provides the specific density and sound speed values the fluid model previously had to assume. Classical fluid acoustics dictate the mechanical motion, and prime number theory provides the exact dimensions. The two frameworks describe the exact same physical structure of reality. This prime-structured fluid yields a baseline unit of measure, the acoustic quantum, denoted mathematically by the number 108. This 108 isn't a random sum, it's the product of two specific physical properties. The first is the fluid's quadratic dispersion, which squares the energy of its waves. That gives us a factor of 2 squared. The second is the medium's underlying potential structure, which is encoded by the cubic prime as 3 cubed, or 27. Together, they generate the master unit of 108. As a fundamental particle in the standard model corresponds to a standing acoustic wave vibrating at an integer multiple of this 108 unit. The weights of the known subatomic particles lock exactly onto this scale. The physical geometry of an atom follows this same prime-coded sequence. The simplest channel, prime 2, dictates the capacity of the spherical s orbital, allowing exactly 2 electrons to occupy that shell based on the quadratic reciprocity of the medium. Prime 3 governs the p orbital with its capacity of 6. Primes 5 and 7 determine the structures of the d and f blocks, precisely matching the complex magnetic substates observed in the periodic table. The math of the prime dictates the physical volume of the electron cloud. The existence of mass and the architecture of atoms are rigorously sculpted by the mathematical laws of prime reciprocity acting on a fluid vacuum. Zooming out to the macro scale, This model of the universe perfectly aligns with equations describing a Bogoliubov fluid. Physicists already utilize models of rotating quantum superfluids to simulate the gravitational warping of spacetime. Treating the vacuum as a continuous, dispersive fluid programmed by primes provides a coherent bridge between the microscopic mechanics of atoms and the vast cosmological forces of gravity. Actual particle physics experiments verify this framework. The exact mass of the Higgs boson, responsible for giving other particles their mass, emerges as a natural outcome of the quintic, or prime 5, mathematical channel. This shift in perspective extends to the most basic units of physics, including Planck's constant. For over a century, this number has served as a fixed, fundamental rule for the scale of quantum action. Under this synthesis, Planck's constant is actually the derived dispersive coefficient of the underlying vacuum superfluid. It is a physical measurement of the medium itself. The universe is not governed by random rolls of quantum dice. It acts as a finely tuned acoustic instrument,